Alright, so here are the multiple choice questions, and I will do an answer key for you. So I'm just going to go through each one by one for you. Alright, so this one's asking me to do a limit to infinity. Also, press pause if you have form B. I believe I'm using form A. It just means your questions are in a different order, so you got to go and find them, that's all. Alright, so number one, if I'm going to infinity and this is a rational function, then I'm going to circle the highest power in the numerator, highest power in the denominator, and I'm going to simplify. And because this is easy, it gives me 3. That is the answer. It's actually also the horizontal asymptote of the function. Y equal to 3 is the HA. Alright, number 2. If the limit as x goes to a equals a number, what has to be true? Well, this is easy. Has to be a because it's the definition. The definition states that if the left side and the right side limits are the same, then the limit itself will exist. Why does B not work? Let me erase this line out of the way. So why does B not work? Well, B is the definition of continuity, and this statement doesn't say anything about continuous, it just says the limit exists. So it can't be B. Also can't be C because it says exactly the same thing. F of A equaling L. F of A equals L is another way to say continuous, and therefore it's not. Therefore, just to prove to you that A is definitely the answer. Number 3. Where is the removable discontinuity? Well, I'm telling you there's a removable. Or actually, no, I'm not, because one of your answer choices is none exists. So we have to prove that there is one. So the first thing I'm going to do is factor. The numerator is easy. 2 numbers that multiply to 6 but add to -5, and that would be these two. The denominator is what you guys keep getting incorrect. That's a cubed minus b cubed, and that would be a minus b. Oopsie, I'm going to run out of space. Sorry, it's a little bit difficult to write on a tablet to do this. A minus b times a squared plus ab plus b squared. So everything else is plus. Alright, so what do we get in the denominator? Well, a is x and b is 2. Therefore, I'm going to substitute everything in. X minus 2 times x squared plus 2x plus 4. So there is a removable discontinuity. It's at x equal to 2. How do I find the removable discontinuity? I substitute back into the simplified form. So I get 2 minus 3 in the numerator. In the denominator, I get 2 squared plus 2 times 2 plus 4. So the numerator, I get -1. The denominator, I believe I get 12. So the answer would be 2, -12. Which of the tables shows the limit as x approaches 2 is equal to 4? Well, I can show you which one definitely isn't. This guy. This actually shows that there's a jump discontinuity at x equal to 2. Most people knew that number 3 definitely showed the limit because you see the pattern of numbers from the left and from the right approach 4. And then number 1 was the one people got confused on. Well, you can see that there's a pattern of numbers going towards 4. The part that people got confused about is the fact that there's an error there. So what could potentially be happening? What could be happening is a removable discontinuity at 2, 4. So what does that mean? When you look in your table won't give you a value of 4 at 2 because it's a removable discontinuity, but all the numbers approaching from the left and right will go towards 4. The answer was letter D. Number 5. If the limit from the left is -5 and the limit from the right is +1, what could occur at 3? Well, number 1, removable discontinuity can't be right because the limits would actually be the same. So if I go from here to a removable and keep going, what you'll notice is the limit from the left and the limit from the right go to the same value, whatever the y value is of that removable. So it can't be A. Infinite discontinuity. Well, it's called an infinite discontinuity because the values go on infinitely, like a vertical asymptote. A vertical asymptote has limit values of positive or negative infinity coming in from the left and coming in from the right. So it can't be B. A jump discontinuity. Well, you go to a value, you jump up and go to another value. Is that what's happening? Yes, it is. The values are different, but they're both values, so it's jump discontinuity. We know it can't be continuous because the left and right limits would have to be the same, and oscillating, remember that's that crazy one, we can't even pinpoint the value. Alright, number 6. Now we're going to, as n goes to negative infinity, but this is rational, so I'm going to take the highest power in the numerator, highest power in the denominator, simplify, and I get negative 8n cubed. So 2 methods you can do. That's an odd, supposed to say odd, negative. Odd negatives look exactly like a line with a negative slope. Therefore, the limit as x approaches negative infinity would be the left side of that line, and therefore the answer is positive infinity. I'm going to show another method that people used, which was, we know that n behavior is negative 8n cubed, and what people did was negative 8 times negative infinity cubed. Well, if you cube a negative number, it stays negative. So you did a negative 8 times a negative infinity, because infinity cubed is still infinity. The negatives are still there, therefore negative times a negative makes a positive. And that should have been an infinity, sorry. So both ways give you the answer of positive infinity. Number 7, evaluate the limit from the left side. So you got to figure out what sides you're looking at. This is the left and this is the right. This is the value at x equal to 1. It only asked me for the left. Therefore, I would do 1 squared minus 2, which gives me negative 1. Number 8, evaluate the limit of the function. So most of you were used to seeing this. Small on top, big on bottom, therefore the answer is 0 because the bottom gets extremely huge. And order of magnitude says when the denominator is way bigger, we're going to go towards 0. Well, in this case, the fraction has been flipped. It is now the reciprocal fraction. And when you do that, and that was actually supposed to be an x, sorry, a typo on the test, I remember that. If we're going towards infinity, e to the infinity over cosine of, let's say, in a sense, infinity, really is what you're looking at. The top gets huge. The top is easy. We know that that is going towards infinity. The denominator, though, ranges from negative 1 to 1. And if you remember us talking about this problem, when you take a big number and you divide it by numbers that are bouncing between negative 1 and 1, well then, you're going to have a huge number, but that huge number is also going to bounce between negative and positive. Negative and positive. Why? Because of this guy. You're going to keep dividing by a tiny number between negative 1 and 1, but sometimes the number will be positive, sometimes the number will be negative, and therefore you're going to go towards positive and negative infinity, which means you can't select one of them. The answer is does not exist. Number 9, given the function that's there on the interval of 1 to 2 where f of c equals 4. So first of all, these here are x values. This here is a y value. Some of you use the argument that 4 is not within 1 to 2, and therefore it doesn't hold. That makes no sense because we're talking about y value there. Alright, so we know this is an IVT problem, so the first thing I'm going to check is continuity. Well, I know I have an issue at x equal to 1/2, because that would make the denominator 0, but since it's not within 1 to 2, I don't have to worry about it, so this passes the test of continuity within 1 to 2. I know that it's closed because I gave you the close, and there's no discontinuity at x equal to 1, and there's no discontinuity at x equal to 2, so it's closed. So those two things are good. Well, what you'll notice is number 2 can't be true because it does hold continuity. Alright, third thing, you should be checking your y values. So, what are we checking? Y of 1 would be 6 plus 5 minus 4 all over 2 minus 1, which is 1. So I get 7. And then I get y of, oh, what's the other value? 2. 2. 6 times 4 is 24. Plus 5 times 2, and then minus 4 all over 4 minus 1 is 3. So I get 30 over 3 which is 10. And then the next piece is, now that I know the y values, I got to check if this y value is guaranteed by the range. The range is from 7 to 10. 4 is not within that range. Therefore, 3 is true. It doesn't hold, so 1 can't be true. Therefore, the answer is C. Those are the steps. Number 10. Given the graph to the right, which statements are true? The limit as x goes to negative 2 from the left side, that would be here, goes to negative infinity. Yep, that's right here. The limit as x approaches negative or positive infinity, that'd be here. This approaches 1, here. This approaches 1. And then the limit as x approaches negative 1 is equal to f of negative 1. Well, this would be the limit value, which is 3. This would be the y value, which is negative 2, and they are not the same. Therefore, 1 is true, 2 is true, but not 3. Therefore, C. Number 11. Determine the average rate of change is the same thing as plain old slope. That would be f of 4 minus f of 2 all over 4 minus 2. So let's just double check. F of 4 would be 4 ln of 3. F of 2 would be 4 ln of 1. The ln of 1 is 0, therefore this one's 0. Now that I have those values, I'll come back up here. I get 4 ln of 3. F of 2 was 0, so I'm not going to even bother writing it. Divided by 2, therefore I get 2 ln of 3. Things that you can't do. 4 ln of 3 minus 4 ln of 1 does not equal 4 ln of 2. You can't just go and subtract 3 minus 1. It does not work that way. Those are functions. Let's see. Therefore, the answer was 2 ln of 3. There's the answer, 2 ln of 3. Number 12, what's the instantaneous rate of change? Instantaneous rate of change is the same thing as derivative. Now you know the new notation, f prime at x equal to 9. You guys needed to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Going across, the limit as h goes to 0 of f of x plus h would be the root of x plus h minus f of x, which would be the root of x, all over h. To simplify this guy, I'm going to multiply numerator and denominator by the root of x plus h plus the root of x, all over the root of x plus h plus the root of x. So what do we get? We get that the limit as h goes to 0, the numerator, that's the a minus b times a plus b, which gives me a, which is the root of x plus h, squared minus b, root of x, squared. And then the denominator, we still have the h right here, multiply by, and a lot of you forgot the set of parentheses right here, we're multiplying by this whole quantity right there. Next piece, I'm going to simplify the numerator, and I get the limit as h goes to 0 of x plus h minus x all over, and the denominator I am not multiplying out. I'm going to keep it factored and nice. The numerator, we get that the x's cancel, and we end up with the limit as h goes to 0 of, that h would cancel to 1, therefore I have 1 over the square root of x plus h plus the square root of x. Here, h goes to 0. Now I finally get to put in my limit value of 0 because I canceled this h right here. Therefore, my answer would be 1 over the square root of x plus the square root of x. When you add two things that are the same, you get two of them. So that is the derivative, and now I'm going to do it at 9. I'm going to do the derivative at 9, and that would be 1 over 2 root 9, which would be 3, and that would be 1/6, D. Number 13, remember we said once you see an absolute value, I want to see a graph. Do you know what the graph looks like? Maybe not. Things that you should notice, the numerator can actually factor to 2 minus x all over absolute value of x minus 2. That is the same thing as me writing this, which helps you to look at it and makes you want to say, oh, well, let's just cancel these guys. You can't cancel them because of the absolute value. That is why I keep telling you, make a table, create a graph. Because this is there, it makes the graph really easy to make. You know the problem's at 2. You know at 2, it's undefined because the denominator would be 0. So pick a number after, pick a number before. If you substitute in positive 3, you end up getting negative 3. If you substitute in positive 1, you get negative 3 times negative 1, and that gives you positive 3. If you're not sure, check some more values. Try 2.5, try 4, try 100, and so on. The graph at x equal to 2 looks like this. Coming in from the left side is positive 3. So this is coming in from the left, and from the right side, it's negative 3. The answer to this guy was negative 3. All right, number 14, show algebraically if there's a horizontal tangent. This one is a little bit of a pain. F prime of x would equal the limit as h goes to 0 of f of x plus h minus f of x all over h. Well, why am I doing that? Because the word tangent tells me I'm going to need the derivative. Now you know the word. The word horizontal means I'm going to take my derivative and set it equal to 0. I want my slopes to be 0, which means I need to find the derivative. So, things that you should know, f of x plus h is equal to negative x plus h squared plus 2 times x plus h. Let's simplify this. This would give me negative parentheses x squared plus 2xh plus h squared plus 2x plus 2h. So all I'm going to do is rewrite this down here. But I'm going to write it into my fraction. So f of x plus h, this first part, I'll put in purple. I'm just rewriting what's up here. Negative x squared minus 2xh minus h squared plus 2x plus 2h minus f of x. That would be this part right here. F of x is the original function negative x squared plus 2x and all over h. So, what do we get? We get, and I'm going to distribute my negative, which makes it a little easier for me. The negative x squared cancels with the positive x squared. The 2x cancels with the negative 2x. This whole f of x always cancels if you do the problems correctly. So that equals the limit as h goes to 0. I'm going to factor the h out. You get negative 2x minus h plus 2 all over h. The h's cancel. And I'm going to do a limit now that the h is canceled. I'm going to do this to 0. Therefore, you get negative 2x plus 2 is f prime of x. But remember, that's not the whole problem. We want to find if there's a horizontal tangent. Set that equal to 0. You get positive 2x is equal to 2. Therefore, x equals 1. There is your horizontal tangent. Last problem. Number 15. Evaluate the limit. Well, this guy, if you substitute in, that would be the first step. You actually get an undefined. Because the denominator ends up equaling 0, so I have to simplify or factor. In this case, factoring, probably not the best method. I'm going to simplify instead. So I'm going to multiply numerator by x plus 5 plus root of 5 over the root of x plus 5, see, plus the root of 5. Kind of like the conjugate, talked about that. So here's where the major mistakes happen. First of all, when you were writing it out, many of you forgot your parentheses. What do I mean by that? The numerator is 5x multiplied by this whole entire x plus 5 plus root of 5. The denominator, it's that rule again, a squared minus b squared. Oopsie, that's supposed to say x. Sorry, x goes to 0. So the numerator and the denominator, let's see, the numerator would be 5x times the root of x plus 5 plus root of 5. The denominator gives us, and I'm just going to write it right here, x plus 5 minus 5. So I actually get x in the denominator. The x's will now cancel, this x and this x. So I'm really finding the limit as x goes to 0 of 5 times the root of x plus 5 plus the root of 5. What does that give me? Now that the denominator no longer causes an issue, I can substitute in 0 right there, and I get 5 times the square root of 5 plus the square root of 5. Remember? Inside, square root of 5 plus the square root of 5 makes 2 square roots of 5. See? 5 times 2 makes 10 square roots of 5. There are your multiple choice.